In this third video, we're having a look at the other form of the equation of a circle. Basically, we've met this one already, but if I multiplied this lot out and took everything to one side, it would give me this form of the circle. If we've got it in that form where G, F and C are constants, then the centre is minus G minus F, and the radius is this thing here, square root of G squared plus F squared minus C. You can prove it just by completing the square and comparing to the bit above, but you're not required to, and secondly, you are given this on your formula sheet, okay? You're given both versions of the circle, okay? So what we're going to do is we're going to use this today. Couple of other points first. Remember, to be a circle, its radius has to be greater than 0, which really means this thing inside the square root needs to be greater than 0. Okay, because you need to have a radius to make it a circle. And if you substitute into this formula here, there are three, with a point you've got, any point you're given, and you want to see whether it's on the circle, inside the circle, or outside the circle, then if we substitute in our point here, if it's equal to 0, then it's the same as that formula, so it's on the circle. If it's greater than 0, your answer when you plug it in, then it's outside the circle. And if it's less than 0, when you plug your numbers into there, then it's inside the circle. Okay, let's go about using that information in the next few examples. First of all, it's asked me which of the following represents a circle. At first glance, they both look like that sort of thing, so that's okay. Let's have a wee look though. If we looked at the equation A, okay, it's fine for a centre. Remember, divide it by 2, change its sign, so the centre is it's minus, so change its sign, it becomes +5. So its centre it's got a centre. But when we come to work out its radius, G squared plus F squared minus C, if you work that out, that comes to 0. Therefore, this one's not a circle, because the radius is not greater than 0. In this case, it's equal to 0. You've effectively got a point here. B, if we looked at this one, okay, centre, no problem. It's the right sort of form as well, so you've got 2, 3. The radius, well, what have we got? We've got 2 squared plus minus 3 squared plus 38, because minus a minus is a plus. So that's 13 and 38 gives me root of 4151, which is a little over 7. So that one would be a circle. It's got a radius which is greater than 0, because its radius is greater than 0. That was not a circle because its radius was equal to 0. Again, if the bit on the inside had ended up being negative, it wouldn't give us a real solution, so it would not be a circle. Okay, so A is not a circle, B is a circle. Okay, that's the first example. Okay, 2 more examples. Second example. Find the equation of the circle that is concentric to. Remember, concentric simply means it's got the same centre. And if it's got the same centre, then F and G are not going to, G and F are not going to change. So that and that will stay the same. Okay, so we know first of all, concentric, same centre. So we've got G equals -1/2 and F equals 2. We know that. C, however, will change. So first of all, what is our radius at the moment? If we work it out, what have we got? We've got -1/2 squared, okay, plus 2 squared, plus 8. If you work that out, that gives you 3.5. Okay, so the new radius is equal to 7, because it's double it, isn't it? So now we know, remember we said C will change, that's the old C to work out the old radius. So our new radius is 7. And we know G and F are not going to change, so they remain the same. Minus C, okay? So the only thing we don't know there is C. Let's square it. You've got 49 equals 1/4 plus 4 minus C. So 45, 44 3/4. So C will be equal to, minus C will be equal to 44 3/4. So C is minus 44 3/4. Okay, we've now got the last bit we needed, which is C. So we can write down our equation, x squared plus y squared. Remember, these bits are not changing because the centre's the same, but instead of -8, we have minus 44 3/4. Okay, so all we did was took the old radius, doubled it, because they told us it was twice, so it gave us 7. Then we used our r equals square root of g squared plus f squared minus c, and worked out what the new c was. Okay, so that's one where they've changed the radius but kept the centre the same. This one, find out whether the points A, 1, 3 and B, 1, -1 lie outside or inside the circle with this equation. I've used the same circle. Okay, so all we do is substitute in. So look, for the point A, what we've got is we've got 1 squared plus 3 squared minus 1 plus 4 times 3 minus 8. That's just substituting that for x, that for y into this equation. And if we work that out, you will find it gives you 13. Now, as 13 is greater than 0, that means it's outside the circle. Let's try the other one, 1 minus 1 for B. So, 1 squared plus minus 1 squared, okay, minus 1, okay, plus 4 times minus 1, and lastly minus 8. Okay, just taking 1 for x minus 1 for y, plugging it into this formula again. And if you work that out, that gives you minus 11. And as we know, minus 11 is less than 0. This means B is inside the circle. And remember, if it had been equal to 0, either of these, it would be on the circle. Okay, that's just a few examples of how to use this new formula for a circle. You should now be able to do the third exercise.